Okay, so you guys, the notes are online today because I'm over at the meeting about the visit and the people that are coming to visit the school today. So I'm recording the lesson so that you can watch it and not get behind and also not have to have a sub teach it. So one thing that I want you to write down at the top of your notes today is that tonight when you do your homework, you have to do homework 24.1 and you have to do homework 24.2. So in the computer, they're separate. Don't forget to do both of them. You can do them on the same piece of paper if you want to, but just make sure that both of them get done. So we're going to start a new section. So all the lessons in this are about quadrilaterals. A quadrilateral is defined as being a polygon with 4 sides. Now you can probably think of a lot of different shapes that have 4 sides. So rectangles, rhombuses, squares, parallelograms are one of them, kites, trapezoids. So there's a lot of different shapes that are special shapes that have 4 sides that each have their own properties. And so that's what we're going to be learning about. Today's notes are all about parallelograms. So a parallelogram is a special type of quadrilateral that has certain properties. And we're going to write down what the properties are right here. A quadrilateral, though, is just any shape that has 4 sides. And so I tried to draw this kind of weird so it didn't look like a square or a rectangle. But when you draw a parallelogram has 2 pairs of sides that are parallel, and it has another pair of sides that's parallel over here. And usually when you see a parallelogram drawn, it'll be drawn like this, so it kind of looks like a slant. This side is parallel to this side, and then this side is parallel to this side. And so the definition of parallelogram is it's defined as being a quadrilateral with both pairs of opposite sides parallel. And so these 2 sides are parallel and these 2 sides are parallel. So when you look at a parallelogram, both pairs of opposite sides are parallel. And so that's the definition of parallelogram. So this side's parallel to this side and this side's parallel to this side. So that definition, or this fact, is actually the definition of parallelograms. So you can write that on the picture. And then I'm going to write definition of parallelogram underneath this because we might need to use that as a reason later in a proof. In addition to that definition of parallelogram, there's also a bunch of other properties about parallelograms that are opposite or that are also true. So the first one says both pairs of opposite sides are. We just said they were parallel, but the other thing that's true about parallelograms is that both pairs of opposite sides are also congruent. So this side is congruent to this side, so they're the same length. And then this side is congruent to this side, so those 2 are the same length. Both pairs of opposite angles are congruent. And so in a parallelogram, this angle and this angle are the same, and then this angle and this angle are the same. All 4 pairs of same side interior angles are supplementary. Now we don't have a way to draw that on the picture, but I just want to remind you that this is a parallel line to this. So this is sort of a transversal in this example. So this angle and this angle add up to 180, this angle and this angle add up to 180, this angle and this angle add up to 180, and then this angle and this angle add up to 180. And then the last thing that's true about parallelograms is that both diagonals bisect each other. So the diagonals aren't congruent to each other. Diagonals, so this is a diagonal, and then this is a diagonal. This one's shorter than this one, so they're not the same length, but this one gets cut in half, and then this one gets cut in half. And notice how I'm putting extra markings on those. I already used 2 to say these 2 sides were congruent and 1 to say that these 2 sides were congruent, but then on the picture, I gave these 3 and I gave these 4. You always want to use different numbers of lines when you do the markings because otherwise it means that like this one is congruent to this if they both have 2, and that's not true. So if I'm trying to show you that something is a parallelogram, I can prove any of these things. There's one special way that you can prove something is a parallelogram that's kind of different than doing, any of these bullet points up here. if you can show that one pair of opposite sides is both congruent and parallel, then you can prove that something is a parallelogram, and that'll come up later. So we'll practice that as it comes up. Looking at the example 1 and example 2 here and here, it says find the value of x and y, and then it says what is the measure of angle A. This one says find the value of x and y, what is the measure of angle A. On both of these, they're supposed to tell you that you're given that ABCD is a parallelogram. So I forgot to write that. So I'm going to write it on number 1, and then I'm going to write it on number 2, given ABCD is a parallelogram. So if they didn't tell me that ABCD was a parallelogram, then I couldn't apply what I'm about to apply to this one, but because I am given that, then I can use what I know about parallelograms to help answer these questions. So the first one says they want me to solve for x and they want me to solve for y. So look at where the two x's are located. You have one x that's down here on the bottom, so this one, 7x, this one right here, and then I have 5x plus 19 up there. Those are opposite sides. And one of the things about parallelograms said both pairs of opposite sides are congruent to each other. So to solve for the yellow in number 1 to find what x is equal to, I'm going to set 7x equal to 5x plus 19. So because this is a parallelogram, this side and this side are the same. So I get 2x equals 19. And then when I divide both sides by 2, I get x equals, I'm going to convert it into a decimal. So I get x equals 9.5. So that's one of my answers to the question. When I answer the second part of the question, I'm going to look at what I see written in the picture. So for this one, I have a y right here, and I have a y right here. And so those angles are opposite from each other. They're across from each other in the parallelogram. And this one right here says both pairs of opposite angles are congruent. So when I solve for the orange, when I solve for y, I'm going to set 8y minus 17 equal to 6y plus 5. And then I'll go through and I'll solve for y there. You're not always going to be setting them equal to each other, but in this example, to find the two things that we needed to find, I did set them equal to each other to solve. So I do that and I solve and I get y equals 11. So I found x and I found y, which was the first thing that they wanted me to do, but then it also says right here, what is the measure of angle A? And so to find the measure of angle A, it's a little bit tricky because you have to think about what you're trying to find. I can't just straight up find the measure of angle A by looking at the picture. I just figured out that y was 11. So if I look at the measure of angle A, and if I look at either of these two angles right here, angle A in this one is a same side interior angle. Angle A in this one is a same side interior angle. So if I plug in the 11, let's plug it into this one. So 6 times 11 plus 5 is 66 plus 5, and so that gives me 71. This angle isn't 71 degrees, but this angle is 71 degrees. And if I plugged the 11 in here, I would also get 71 as my answer. So to figure out the measure of angle A, I need to use this property that says all 4 pairs of same side interior angles are supplementary. So to find the measure of angle A, I'm going to do 180 and I'm going to subtract 71, because if this angle is 71, these two angles have to add up to 180. And so I'm going to get the last answer for this question is that the measure of angle A is equal to 109 degrees. And so those are the 3 things that they wanted me to find here. So you guys, when you do the next problem, it's set up exactly the same way. So you're going to use the same 3 rules. So you're going to say these two sides are across from each other and opposite sides are congruent. So I'm going to set those equal to each other and solve. And then I'm going to use this one, and I'll use the same rule up above that says that opposite angles are congruent to each other, and I'll set that one up and solve. But when you find the measure of angle A on this one, A is one of the ones you don't know, so you'll have to do the same thing and minus the 180. Minus it from 180. If they wanted me to find the measure of angle B instead on this question, or the measure of angle C instead, sorry, B or D, I wouldn't have to do the minus 180 part, because if they wanted me to figure out how big the angle D was, I would just solve for X or solve for Y, and then I would plug it in to find this one. So you only have to do the minus 180 part if you're solving to find one of the other angles that are inside the shape. So let's do the work and solve for this one. Let's start with the sides. So for the sides, 3y minus 1 is equal to y plus 15, and then I'll solve for y. So I get y equals 8. And then I'll solve for the angles over here. The reason why I'm setting them equal to each other is because that's what the property says that I just listed up above. So it said opposite sides are congruent, and then it said that opposite angles were congruent. So from when I solve for x, I get x equals 14. So if x is 14, I can figure out how big either one of these angles are. And then once I know how big either one of these angles are, I can minus it from 180, since I know that this angle and this angle are supplementary. And I also know that this angle and this angle are supplementary. So let's see. I'm going to plug it into the 10. So 10 times 14 minus 19 gives me 140 minus 19, which gives me 121 degrees. So if angle D is 121 degrees, that means that angle B would also be 121 degrees. But they want me to figure out how big angle A is. And so to figure out the measure of angle A, I'm going to do 180 take away 121. And so for this one, I'm going to get that the answer to the question is 59 degrees. So that's how big the measure of angle A is.